For today's tutorials, we're going to talk about how we can use cosine similarities for item-based recommendations. So first, we need to import the pandas libraries. Mostly it's going to be used for handling the CSV files. We also import the NumPy library, as we will be working with the lists and sets a lot. And of course, we want to compare the similarities between the items. So we want to use the pairwise matrix, which has the cosine similarities function. Next, we want to import the H&M dataset. So if you look at here, we can see that it has a lot of informations that can be utilized, but we'll be focused on these transactions and the article. So basically in the transactions, it has the customers and the items that they bought. The customers, they can buy many items at once, and in here just some numbers which isn't very interpretable. So if we want to know the actual product names, we need to look up the article ID, and we will able to see the product name in here. So now let's load up the transactions data using the panda red.csv, and now copy this path and put it in here and do the same things for the article. So the transaction, it has a lot of data, so we want to limit to only the first 100 transactions. So now if we try to print the transaction, so here's a few data, and we have the customer IDs and the items that they have bought. And now for the article. So basically we have a list of all of the articles and the name of the product. So the idea is first we want to combine them together before we do any further processing. So we want to create a dictionary which map the article ID and the product names together using the dictionaries functions. Combine them into a tuple. Now we are looking at the article ID. The second parameters of the tuples is the product's name, and put everything here. And if we try to print it, we see the mapping. So we have the article ID and their product named. Now it's for the transactions. We want the product names to exist in the transactions. So what we want to do is to create a new column, which is the product name in the transactions data frame, by combining the article ID, and we mapped it with the dictionary that we have just created, and it will map the article with the product first. And because we don't want to have the article's ID anymore, we just want to have the customer ID, which equals to the one who bought the items and the actual products that they have bought in here. and we remove all of the others columns. So if we try to print it, see that we have the customer ID and the names of the products that they have bought. In item-based recommendations, we want to show the items that are frequently bought together by user. In here, for this user 00578, he bought two of these products together. So we're gonna put these two in the same group and do the same things for this one. So how we can achieve that is by using the data frame group by function, because we want to group by the customer. So we add the customer ID and we get the product named and we transform them into a list. And now if we print it, we will see that the items from the same user are put in the same array. So this is gonna be our group 1 and this is gonna be our group 2. We also want all of the unique items, so later on we can create our vectors based on the items that exist. So we use the set. So in here on the values they have to be unique, and we put in the products named and we use the words unique like this. And if we print it, we see that we have about 73 unique items. From this all unique items here, we can now create a vector, which will be useful for measuring how each of the vectors are similar together and recommending the most similar vector. First, we create an empty vector, and now there's gonna be a list of items in the group item. So we can just try to print that, and we'll see it here. It looped through all the group items, and when we loop to that, we're gonna do a little check. We're gonna put 1 if the item exists in here, then we're gonna put a 1. If not, we're gonna put a 0. For example, like we have 1 and 1 here, but so for some other items it's gonna be 0 0 0 0. And now we can actually check the vector. So print this. So here's our vector. As you can see, in the first times we have 2 items in the group 1, right? So it's gonna be equals to the 1 here and the 1 here. Next, we want to add all of those vectors and put them into a matrix. We also want to pass it into NumPy array for faster calculations and some helper functions. We're gonna need some helper functions to transform from item into index. So let's write that. So for the item, we're gonna check the index of that item using the enumerate function, and look up based on the unique items. So if we print this, we'll see that here's our item, and we're gonna have the index, which is just a number. The first item's index is gonna be 0. The second item's the index is gonna be 1, and carry on until the last items, which have the 72. We also want to do that the other way around, which we want to map the index to items. So this is going to be useful after we have made the recommendations and we have a list, a vector, and we want to transfer all those vectors back into the items. And here you can see is that we put the index up front and the item is behind, and using the functions that we use from the previous step. So if we print this, the value is going to be the opposite. In here we have the index is set at the front, and the items is actually put after. So now for our final recommendations, we want to create a list of queries that will be measuring the similarities. So in here, let's search for this item, Perry trash. You can pick any items you want. And next one is we're gonna pick the glance tonic, which is this one, and put in here. So for example, if user bought 2 of the items, and what is the next 5 recommendations we want to give them? Like that is the questions. First, we want to transform them into index by using the items to index functions that we have just defined in the above step. And we put the items. So this item actually come from this looped over here. So we looped through all the items in the input items, and we check if that item exists in the index. Then we're gonna put them into our list of index right here. So if we print it, we're gonna have 1 and 8, which is equal to this index and this index. So if items does not exist in this data set, can call it that way, then we just print that input items doesn't exist and there's nothing we can do. But if that items already exist, then we can further process that by transforming from the index into the vector. So now we have vector, and we get all of the data, and we input indice in here. Then if we print it, we're gonna see 2 vector. So in here, this is our Perry trash, and in here this is the vector representing the class tonic. Now we want to combine them together. So it's possible to measure them differently, but we can combine them together because they are bought together. So now we use the aggregated vector and we combine them together using a summed, and kind of use inputs vector, and we use the axis is 1, meaning that we will sum by the rows data. So we're gonna combine this and this, this and this, sum them up. Now we have our query. We want to get the similarities, and using the sklearn cosine similarities function. First we input our aggregated vector along with our vector matrix. So we need to transform them into the same shape. So in here this is a matrix, and in here it's just a sum of rows. So we need to have them in the same format. And we have the cosine similarities, which comparing between our aggregated vector with all of the 73 item vector. So if the value like closer to 1, it means they have high similarities and it is better, and we should use them for recommendation. Now we want to get the index of this high value, so let's use this one, and we kind of sort it like this. So we want to sort them by descending order, so it's gonna do like this. Which gonna sort them in the descending order. Here we have like 1 and 2, like very similar value. So this value is gonna be equals to some of these values right here, and the rest is gonna be just 0. So we just want to pick the top 5 and use them as recommendations. So from the index we want to transform back into the product's name. So we want to use the index to item function, and we put in the index, and we're gonna have for loops right in here. So we're gonna get the index from the similar indices that we have just created, and we have a little check if the index is not in the input indice, because we don't want to give the same recommendations for the same items that they have just bought. Now we're gonna have a list of similar items, and we can just pick the top 5 by doing like this. So I guess top 5, and if we print that, we're gonna only have 5 value, which equals to the recommendations our system will give to the user when they bought the 2 value.